Hi everyone, and welcome back to another video. Last time we looked at equilibrium expressions and how to write them out. We saw that we had this pork, which was products over reactants equals K. And K is just a number telling us how far our equilibrium is. If it's more than 1, we're going to say it's product favored, and if it's less than 1, we're going to say it's reactant favored. More on that later in the video. We also saw how to write these out. Here we have a chemical equation, and I showed you how to write this out in an expression like this. We have 2 NH3 to the power of 2 because we have a 2 over here in front of our NH3 here. And remember, pork, so products over reactants. Our products over here, so they go on top. We did some challenges like this in our Google Classroom assignment, which you should have tried by now. And we're just going to go through one of these here to make sure everyone's got it. So we're going to take our products on this side, and we're going to put them on top since it's products over reactants. So I'm going to take the concentration of my SO2. I am going to fix this really quickly. We're going to take the concentration of our SO2. One more time. Concentration of the SO2. And there's 2 moles of it, so we're putting it to the power of 2 here. Next, O2, there's no number in front, so that we don't have to put it to the power of anything. So what we can just do is say square bracket O2. So that side is done. Then it's over our reactants here. So over our reactants over here. So the concentration of SO3, sulfur trioxide, SO3, and again it's to the power of 2. And that is it. Then we're going to say this equals our Kc expression. This is just a math equation, and we can put in numbers and we can solve for Kc. I'm going to do that later on. One more thing. You may notice here they're all gases. This was not a coincidence. In fact, when we do expressions like this, if it's a solid or a liquid, so if it's an S or an L, we leave it out. We assume that solids and liquids just equal 1 mole per liter, because they're always really close to that. So we don't include them in our equilibrium expressions. If we see a solid or a liquid, we just leave it out. The reason why we leave it out is because it's just going to be 1. If it's 1 to the power of 2, that just makes 1. And if you're dividing something by 1, it doesn't change the equation at all, so we just leave it out. So we assume that solids and liquids are 1 mole per liter, so we do not include them in our equilibrium expression. Here is an example of this. We have H2O gas, so because it's H2O gas, we do include it. But when we add H2O gas to carbon solid, we do not include it because carbon is a solid here. These state symbols are very important because most of the time we're not going to include water because water is often a liquid. But here we are including water because water is a gas in this state. So the only things we actually include are gases in aqueous solutions, so AQ. Here we have our H2 gas, so H2 is on top here, our CO2, our CO, and the CO is up here. And then what's down below is only our H2O. We do not include our carbon. What I want you guys to do is take these notes down into your books, write this down as well, and then you can move on. So pause the video to do that. We write the equilibrium expressions for the following thing. Remember, we don't include liquid or solids because we assume they equal 1 mole per liter. Okay. Let's try this out. We have our products, but our products are just 1. We don't include them. So it's going to be something over this. What we do in this case is we're just going to say it's 1 divided by this number. We don't include this because it's a solid. So that our answer is actually just going to be 1 over the concentration of CO2. That is our answer, and that equals Kc. Now you may be like, okay, I get why we don't include the solids, so we just have the CO2, but why is the 1 over here? That's because it's products over reactants. CO2 has to be on the numerator or denominator, whatever, the bottom fraction on this equation. So that equals Kc. We're going to try these in our Google Classroom task for today. So we're going to try doing some of these. Equilibrium constant. Cool. What does Kc actually mean? In your notebooks, I want you to copy this down. Kc is a measure of the ratio to reactants to products. If it's more than 1, so if we have more products than reactants, we call it product-favored reactions. This means we have more products than reactants. So products over reactants. If we have more products, Kc is going to be bigger than 1, which means it's a product-favored reaction. Our equilibrium is going to favor the products. If it's less than 1, there's more reactants than products, and we call it reactant-favored. It's just which one we have more of in our equilibrium expression. Lastly, when Kc is very large, I'm talking greater than, this is 10,000. So when it's greater than 10,000, we say products are way greater than reactants, so the reaction has gone to completion. And when Kc is this large, you actually don't need a double arrow. You can still have a double arrow, it doesn't matter. But because it's gone to completion, you could use a single arrow and you'd be totally correct as well. When it's very small, like a very small number like this, we say there's way more reactants than products, and there's virtually no reaction happening at all. So copy those down to your books as well. This is also going to be a Google Classroom task that we're going to try for today. And yeah, try it, and that's your work for Wednesday to Friday. Thank you guys.